Okay, one of the problems with trusting is sometimes you just blindly trust, and I'm guilty of that too. So anyway, it says f of theta equals r, and r equals theta squared plus 3 theta. It says find the area of the shaded region. They give me the figure, and they tell me what the limits of integration are going to be. So what I want to do is I want to look at the picture. And this is the picture over here. What is it a picture of? Well, it's the picture of this thing over here. All right. So what I want to do is I want to just, I would say I could trust them, but I'm going to say, r equals theta squared plus 3 theta. All right. And then if I think about it, I'm thinking about this thing, whipping around and creating a graph over here. It's really going to be like a spiral nature to it. But the bottom line is I just want to see if at 0 what the point would be. So when theta equals 0, I'm thinking to myself, if I put that in, what would the r be? The r would be 0. So this stands to reason, by the way. Now, whoops, sorry about that. I'm kind of marching along, and the r's are getting bigger and bigger. By the way, I kind of expect that, right? If I'm marching along, theta's getting bigger. What am I saying then? I'm going somewhere. Where am I going? Well, it looks like I'm going up here where the theta would be pi over 2. Well, what's the r going to be in that case over there? I'm checking. That's all I'm doing, checking. So it's going to be, pi squared over 4. And then plus 3 times pi over 2. I hate to do ballparks, but I am going to do a ballpark. Pi over 2 is, let's say pi squared is about 9 quarters. That's this about. And 3 pi over 4 is about 9 halves. What does that give me? I'm going to say 4. And you get 9 plus 18 is 27 quarters. All right? By the way, this is a really rough figure. I'm not saying this is right by any stretch of the imagination. 4 goes into 27, I don't know, around, like 7 times 4 is 28. So I'm going to say around 7 times. And I'm seeing that. I mean, these are just, really rough numbers we're looking at. So I'm convinced of this now. All right? So let's go back over here. Let's erase this over here. I'm convinced that the picture I've been given, it's, roughly right. All right? I'm not really doing much computation there. And I got to get the area of this thing over here. All right? How are we going to do that? Well, I'm going to go back and put it down. So what do you get? We're going to start at 0. We're going to stop at pi over 2. And then what do we do? It's going to be, let's see, 1/2. It's going to be theta r squared, but the theta is d theta. We're taking little tiny sectors. And what's the r? It's theta squared plus 3 theta. Now, what are we going to do with that? We're going to square it. So we're going to point out 1/2 theta r squared. This is our differential, though. All right? What are we going to do now? I got to do it. So let's write this down. So what are you going to get? 1/2 0 to pi over 2. That's going to be, let's see, theta to the 4th power. And then you're getting, by the way, what we're doing is we're doing theta squared plus 3 theta times theta squared plus 3 theta. So you're going to get, 6 theta cubed. That was pretty easy. Plus 9 theta squared. D theta. I'm going to integrate that, and you get 1/2 theta to the 5th power over 5 plus, that's going to be theta to the 4th power, and you get 6 divided by 4, which is going to be 3 divided by 2. Let me see if I said that right. 6 divided by 4 is 3 divided by 2. Not bad. Let's keep going. What's the next thing I'm going to get? Well, it's going to be theta cubed. Divide by 3, you get 3 over there. What's my limits of integration? 0 to pi over 2. I got some work to do, and I want to point out that it might be tedious, but I have to do it, and then I'll check the key to see if I get the right number. Before I do it, though, I want to get a common denominator. And what would that be? Looks like 10. And you would get 2 theta to the 5th power plus 15 theta to the 4th power plus 30. Let's see, that would be theta to the 3rd power, right? And again, you might say I'm delaying the inevitable. Maybe. I'm trying to make the arithmetic easy for me. I'm kind of looking at this, and the first thing I do is I do notice that it's now 20 on the bottom. 2 times 10 is 20. What I'm going to do now is I'm going to factor out theta cubed. And what are you left off with then? 2 theta squared plus 15 theta. I'm sorry, I factor out a cube, right? So not theta squared, just theta. And then plus 30. And whoops, sorry about that. I didn't mean to do that. Limit integration from 0 to pi over 2. I know it's tough. I got to do the arithmetic now. So what do you get over there? Well, you cube that number, you get pi cubed over 8. Now, 2 times pi squared over 4 is pi squared over 2. Yeah, it's kind of nasty. Plus, well, 15 pi over 2. Plus 30. All divided by 20. All right? Now, if you evaluate the 0, it's going to be 0. So just simply minus 0. So I'm really close to getting something here. Let's write this down. Pi cubed. 8 times 20 is 160. I'm going to factor out a half. And what do you get? Pi squared plus 15 pi plus 60. Boy, it really doesn't seem like it's getting any better. So I'm going to multiply top bottom by 2. You get pi cubed, pi squared, plus 15 pi, plus 60, all over 320. All right, let me look at the key, by the way. I don't know if they did all that work. And they did. Except they multiplied it out. Pi to the 5th, 15 pi to the 4. I'm just checking my work over here. Yep, and then it should be 60 pi cubed. Yep, on bottom is 320. All I did was I factored out pi cubed. Same answer. Thank you.